Okay, so this video is on graphing a quadratic function in vertex form, meaning y equals a x minus h squared plus k, where you can easily tell what the vertex is just by looking at the function. So this is the example that I'm going to do right here. Y equals 2 times x minus 3 squared minus 4. So you start by plugging in values and then plotting those points on the graph. So the first point that I'm going to plug in is 3. When I plug in 3, I get 3 minus 3, which is 0. 0 squared is 0, times 2 is 0, minus 4 is negative 4. This is my vertex, 1, 2, 3, 1, 2, 3, 4. Whenever I have parentheses, I start with the opposite of what is in here. So if this was x plus 3, I would have started with a negative 3. And that's always going to be my vertex. So this is your vertex. You can tell by looking, that's why it's called vertex form. It's always this number and the sign with this one. So this would be negative 4. This would just be positive 3. If this was a plus 3, it would be negative 3. So it's always the opposite of this for the x value. And then once you plug that in, you can go either side of the parabola. So I can go 3, 2, 1, 0, or I can go 3, 4, 5, 6. I'll plug in the smaller numbers, so I'll go with 2. 2 minus 3 is negative 1. Negative 1 squared is positive 1. Whenever you square something, it always comes out positive. So I got 1 times 2 is 2, and 2 minus 4 is negative 2. So I get 1, 2, 1, 2. So I'm right here. If I plug in 1, 1 minus 3 is negative 2. Negative 2 squared is 4. 4 times 2 is 8. 8 minus 4 is 4. So I get 1, 1, 2, 3, 4. So I have this side of the parabola like this. I can assume the other side. If there's a point here, there must be a point here. And if there is a point here, there must be a point here. So this is the other side of the parabola. You can verify these by plugging in, instead of 3, 2, 1, I could have gone 3, 4, 5, and I would have, when I plugged in 4, 4 minus 3 is 1. 1 squared is 1, times 2 is 2. 2 minus 4 is negative 2, and you can see I get the same answer. And if I plugged in 5, I'd also get 4, so same solution again. And that's the other side of the parabola. So that's a graph of the parabola. You can see it cuts through the x-axis. So these are called x-intercepts, which we'll talk about in a second. Eventually it's going to cross through the y-axis. So there's going to be a y-intercept up here somewhere. So I want to look at all the different characteristics of the graph. So that's a solution set. This is a graph of the solution set. We get these by plugging numbers in. This is your domain. This is your range, which we'll talk about that in a second also. So some questions are, I'll ask you, what is a vertex? Well, we know that already. That's 3, negative 4. That's the first point. That's at the very peak here, 3, negative 4. I'll ask, is there a minimum or a maximum on this graph? And when I'm referring to the y values, and in this case it's a minimum. It's the lowest possible point there is. So there's a minimum at y equals 4, negative 4. That's the lowest value you're going to get. That also refers to the range. When you're talking about the range, you're talking about the y values. I guess I'll do that now while I'm talking about it. The range of my answers is going to be negative 4, and it's going to continue all the answers all the way up into infinity. So it's just going to keep going and going and going and going. So I would say negative 4 to infinity, including negative 4. I'll never get an answer of negative 5 because my graph doesn't exist down here. So no matter what you plug into this function, you can plug in anything you want. You're never going to get a negative 5 to come out for y because it just doesn't exist in your solution set. That's what you mean by a range. The domain is what you plug in, and you can plug in anything you want into this function. You could say all real numbers, or you could say negative infinity to infinity, meaning I can plug in any x value I want. Even if I plug in an x value over here, there will be a y value way up here somewhere eventually. So I can plug in any x value I want. That's my domain. My range is only negative 4 to infinity. Okay. My axis of symmetry is this line that just goes down the middle that divides the graph in half, and it's at x equals 3. So it's this value right here. And because it's a line, it's a linear function, it has an equation, and the equation is x equals 3. So that's the equation of the axis of symmetry. It's always going to be the same number as the x value on the vertex. Just like your minimum and your maximum is always going to be the same number as the y value on your vertex, and the same number in your range. All of that makes sense when you think about it. So now I'm looking for the y-intercept, and you can only find a y-intercept when the x value is 0. So just plug 0 in for x over here. 0 minus 3 is negative 3. Negative 3 squared is 9, times 2 is 18. 18 minus 4 is 14. So 0, 14, which makes sense, somewhere up here. It will cross the y-axis. So it goes with the graph. You can see that it makes sense. It's a reasonable answer. And then the last thing is the x-intercepts. Now we can see by looking at the graph that there are two x-intercepts here. And we know they're both positive. So we should be looking for two positive answers. And you get an x-intercept when your y value is 0. So all we have to do is go back to this original function and make this 0 and solve this. So I'll do that work over here. 0 equals 2 times x minus 3 squared minus 4. So I'm doing some algebra steps. I add 4 to both sides. 4 equals 2 times x minus 3 squared. Divide both sides by 2. 2, oops, I just cut off the screen. 2 equals x minus 3 squared. Take the square root of both sides. And the reason you're doing that is because taking the square root and squared at the same time cancel each other out, and you just end up with x minus 3. Add 3 to both sides, and now you have square root of 2 plus 3 equals x. So I did plus 3 plus 3. And then we need a calculator to take the square root of 2, which is approximately, I do not have a calculator in front of me. I'm just going to say 1.4. So it's a positive 1.4 plus 3, and it's a negative 1.4 plus 3. So you end up with two answers. So 3, let's say it's 3 plus 1.4, that would be 4.4. And 3 minus 1.4 would be 1.6. And so there's your two answers. And if you look back at your graph, it makes sense. They're both positive. 4.4, 1.6 makes sense. So just make your y value 0. The only thing I wanted to do also in this video was to convert to standard form. So if I had this function, the original function was y equals 2x minus 3 squared minus 4. If I wanted to convert to standard form, I would do x minus 3 times x minus 3 minus 4. And I'm squaring it, so that's why I wrote it twice. And then you would do the FOIL method, x times x times negative 3, negative 3 times x, negative 3 times negative 3. So that's the FOIL, 1, 2, 3, 4. Then I would distribute this 2 to all these terms. Well, first I'll combine these two. So I'll shorten this to x squared minus 6x plus 9. Then I'll distribute the 2 to each term. So 2x squared minus 12x plus 18 minus 4. And now I'll combine these two. So 2x squared minus 12x plus 14. And this is the same function as what we started with, only it's not in vertex form anymore. Now it's in standard form, which is y equals ax squared plus bx plus c. So it's the same function, just rewritten in a different format. And that's it.